All right, now let's look at problem number 8. Okay, so here we need to find the number of integers such that this expression is integer. So here we need to pay attention that we do not specify what kind of integers of n. So it could be positive or negative, and also n could be 0, right? So 0 definitely is it's a valid case, and it's very easy to be missed. All right, so let's look at different cases. Right? So the first one, n is 0, which is definitely fine. And then we look at a case when n is a positive integer. So for this, we have this is 100 factorial times 3 to the n and 5 to the n, right? So this, which is the same as 305 to the power n. All right, so here we are basically looking for 5 to the n. This is a factor of 100 factorial, right? So we are looking for all the possible n such that part of integer, such as 5 to the power n, is it's a factor of 100. All right, so we need to look for the largest of such n. All right, so when it involves a factorial, we have a formula to do that. So the formula is 100 divided by 5, and then plus 100 divided by 25. And then in general, you also need to look at 5 cubed and 5 to the power 4, but the 5 cubed already exceeds 100, so we don't need to consider that. Now, why do we need to consider 25? That's because multiples of 25, they contribute 2 5s, right? At least 2 5s. Okay, so that's why we need to add it. Okay, so then from here, this we get is 20 plus 4, and this is 24, right? Okay, so now we need to consider, so this is for part of n, and then we consider negative n. So n is negative 1, start from negative 1. Okay, so then there is 100 factorial. So here what we have is, I write, this will be 5 over 3 to the negative n, right? Okay, so here we are looking for 3 to the negative n. So keep in mind, this is a positive integer, so positive integer, right? Okay, so onto this one, maybe I just replace this by, say, k. K is no less than 1, so this is a factor of 100 factorial, okay? All right, so then we just apply the same formula. So, okay, so let me put the largest k, okay? So that will be 100 divided by 3, and then 100 divided by 3 factorial, no, divided by 3 squared. Okay, so here, this one just means we choose the largest integer. Okay, maybe let me put it here. So this one notation means the integer part of x. Right? So in other words, is the largest integer that is no greater than x. All right, so then if we put it here, and because it's 3, so we can go to 3 cubed, and then we can go to 3 to 4, which is 81. Okay, so now let's add them together. So let's see what we have. So this one is 33, and this is 11. Okay, and this is 3, right? Because it's 27. Okay, and plus the last one, 81, so it's 1. So let's add them together. Right, so this is 36 plus 12, which is 48. All right, so we have 3 numbers. So first one is 1, so this is only one case, that's just 0. And then we have 24, right? So we have 24, which is 5 for the positive integer n, right? And this is for the negative n, right? All right, so that's what we have. Maybe. So this is for n equal to 1, and this for n less equal to negative 1. All right, so in total, so what is the total? So the total is 1 plus 24 plus 48. That is 73. All right. Okay, so here the main point is do not miss the case n equals 0, and also you should consider n is negative. When n is negative, then if you change the positive, then you have to flip 3 and 5, right? So, and also we should keep in mind, so these are the formulas to calculate the powers, the largest power of something that is a factor of factorial, right? So you should consider all powers. All right, so this is number 8. Now let's look at number 9. Okay, so number 9. So here we have right triangle ABC, so which is the most typical right triangle 3, 4, 5. So here we have angle bisector BE and CF, they intersect G. We are looking for the area of this quadrilateral AGF. Okay, all right. So here the main point is the angle bisect theorem. So let's recall the angle bisect theorem. So angle bisector theorem. All right, so this one says, the theorem says this: suppose I have a triangle, okay, so we bisect one of them. Let's say this is, okay, so I just put as ABC. All right, so here we have, this is the C, and this is C, and this is B. If I put this part is X, and then I put this part is Y, right? Okay, so then what we have, the angle bisect theorem says this. We have the C over B equals to X over Y. So this is the angle bisect theorem. Well, because both of them is the area. So this is the area of triangle. Maybe let's put this one as it is the D. So therefore this is D. Okay, so this triangle ABD over ADC, area of ADC. Okay. All right. So both of these two fractions, they equal the ratio between two areas of triangles. Okay. All right. Now, after we apply this angle bisect theorem, so what we get is we say, okay, so the ratio of this to this is 3,5. And the ratio of this to that, this is 4,5. All right. Now, given that, so after we identify the ratio between AF, LB, A, and EC, then what is left then becomes quite a standard question in AMC10. And in recent years, it also appears in AMC8 to figure out the area based on those ratios. Okay, so we have two ways to solve this problem. Given those ratios are provided. Method 1, we just based on areas. Okay, so this is just area method. All right, so what we do is, let me divide AG. Okay. I put this part as say area is X, this part area is Y. Now, then if you look at the area, because this is 3 to 5, so here is, we know it's just 3,5. So then I get the area of this one. This will be 3 to 5 and times X. And the area of this will be 504 times Y. Well, that's because if you have two triangles, they share the same height, then the ratio between the areas is just the ratio between corresponding sides. Okay, so that's what we have. All right, now we are going to set up two equations. Okay, so we got two equations. So equation 1, if I look at a triangle AFC, so AFC, I have X plus Y and plus 3 over 5X. This one equals to the area of AFC. The area of AFC is the total area we know, which is 6. So that's 6 times the ratio is 9, 4 over 9, right? 4 over 9. Okay, so then we get this one is 3 to 8. So that's equation 1. Now equation 2, let's look at the area of ABE. So the area of ABE. So for this one, we have is X plus Y plus 5 over 4Y. This is the area of ABE, which is 6 times the ratio. That's 3 over 8, right? Okay, so that's 4 to the 9, right? So that's 4 to the 9. Okay, so now you see we have two equations, right? So we have two equations and four unknowns, two unknowns. Okay, so let's solve this. Okay, and from here we can solve, right? So I have two equations, equation 1 and equation 2. So from here I can solve the x equals to 3 over 4 and y equals to 2 over 3. So that's what we have. Now you just add them up. So the area is x plus y, and then you get 17 over 12. Okay, so this is the first method. All right, now let's look at the second method. So the first method, we just use areas, the ratio between areas to figure out the area of this quadrilateral. Now let's use the second method, which is based on similarity, or you use Mini Log Theorem. What we wanted to do is want to figure out what is the ratio between BG over GE. Okay, so we focus on the this part of the figure. Okay, so the yellow part, and I do a notation so that put in a position which is the typical way that people put it. All right. Okay, so we want to figure out what is the BG over GE. We have two ways to do that. One is we just use similarity, right? Okay, so I say way one is we use similarity. I draw a helping line. So if I do a helping line from the E, so if I draw a helping line, I do this, say E, F, G, let's say this is the edge. Okay, so then I have, let's say we draw a helping line, which is E and H. Okay, so then we have this AH by similarity. We have this AH to FH, so this is the same as 3, 5. So this is 3, 5. Okay, so then we can quickly figure out from the picture we see, all right, so then what is the BG over GE? BG over GE by similarity, so this is the same as the BF over FH, right? What is BF? Well, BF, you can take the ratio is because 5 commas, so you can choose the 5. And FH is 4. And then you have FH, AH is 3, 5, right? So then you can put this one is, this just 5 over 8, right? 5 over 8. Okay, so now you do some cancellation, you end this up, this end up is 2. Okay, so we get a BG over GE equals 2. So we get this. Now we can single out, let me single out the triangle. Then we have the triangle here. And this is the B, F, G, A, E, okay? So I have this to this is 5, 4. And I have this to this is 2, 1. All right, so now we know the triangle of BFG over the whole triangle ABE. So from here you get this will be just 5 over 9, and then you multiply by 2 over 3. Okay, so which is 10 over 27. Okay, so now in particular, so from here we get this quadrilateral, so which is AFGE over the whole ABE will be 17 over 27. And we know ABE, so okay, so then from here, we just get the area of AFGE is, we know the area of the whole thing ABE, right? So this we calculated before. So ABE, so this equals to, let's recall, so it's 6 times 3 over 8, right? So that's 9 over 4. Okay, so then this will be 9 over 4 times 17 over 27, and then just a cancellation, we just get 17 over 12, right? We recall the same result. All right, so this is we do by way one, we use similarity, and also we can do we can find the ratio by Mini Log Theorem. So way two, we use the Mini Log Theorem. So let's recall the Mini Log Theorem. So let me redraw the picture here. This is B, A, G, right? Okay. So we have F, G, C. Now the Mini Log Theorem says this: the ratio of this to that. We finish the Mini Log Theorem. What you do, the ratio basis circle. Okay, so then you from A to C, and back to C to G, and then from C to E to G. So this is E. This is E. Okay, so from E to G, and then you back to from G to B. Okay, so let me write down. And the product shall be 1. Right. So what you should have is B, F times FA, and times AC to CE, and times EG to GB is 1. So this is the Mini Log Theorem. Okay, so this is the Mini Log Theorem. Now by that, we say, okay, so I just plug into those numbers. So the first one is 5/4 AC over CE. So that's 8/5. Okay, so this is 8/5. And then this is EG over GB equals to 1. So from here, you say, okay, we just get EG over GB equals to 1/2, right? Because here 5 cancel with 5, 8 cancel with 4. So all right, so basically we just get the same ratio, right? We get the same ratio, okay? So EG over GB is 1/2, which is the same as BG over GE equals to 2, right? Okay, it's the same. Then we just go back to the ratio between two triangles. All right. Okay, so here we have several points. The number one is the angle bisect theorem, which is the starting point. And after we identify those ratios, then what is left? Either you can go with pure area ratios, that's the method one, or you can use similarity or Mini Log theorem to figure out the ratio of the middle line, and then just go ahead to figure out those areas. All right. Okay, now let's look at number 10. Number 10 says A is a solution to this quadratic equation, x squared minus 6 plus 1 equals 0. Now we want to find a to the power 2020, and it's a reciprocal or to the same power. We add them together. What's the remainder when divided by 5? All right. So here the key point is to realize if A is a solution to this quadratic equation, then 1/A is also a solution. That's because of the Vieta formula. Okay. By the Vieta formula, solution. So we know, like, if x1 and x2 are two solutions of x squared minus 6 plus 1 equals 0, right? Then we have x1, so okay, so by Vieta formula, so we have x1 plus x2 equals 6, and x1 times x2 is 1. Okay, so this implies A and 1/A are both solutions to this equation. Okay, so for convenience, I will write, so I just write B equals to 1/A, so for convenience. All right, so then what we are looking for is A to the 2020 plus B to the 2020. Okay, 2020 is a larger power. What we need to do is to use equation to reduce the power. Okay, so we need to use, the trick is to use the equation to reduce powers. All right, so what we do is, because we know A squared minus 6A plus 1 equals 0, right? So this just means A squared equals to 6A minus 1. Then by a simple algebra, we get the A to the power n plus 2 equals 6 to the power n plus 1 and minus A to the power n, right? So this is what we have. All right, so similarly, we also have the B to the power n plus 2 is also 6B to the power n plus 1 and minus B to the power n, right? Okay, so now we can add them together. So from here, what we have, if I write the capital AN equals to AN plus BN. So what we have is capital AN plus 1 equals to, I combine those two things. I combine these two right here. Okay, so I get a to the n plus 2 equals to 6a to the n plus 1 and minus a to the n, right? A to the n. Okay. Oh. So here's a to the power n plus b to the power n. Okay, so now obviously I have the power 0, so this one equals to 2, and a1 is a plus b, right? Which by the other one right here. So this one equals to 6. All right. Now, because here we are just looking for the remainder divided by 5. So we know, so because this one can be written as 5 times a to the n plus 1 plus a plus 1 minus an, right? Okay, so this one is divisible by 5. So when we are considering remainders divided by 5, this one can be ignored, which means we should have is a n plus 2 have the same remainder as a n plus 1 minus an, right? So this is modular 5. For n, you can start from 0. Okay, so this gives us a recurrence relation, right? Of course, from this formula, you see, it's very easy to see if a0 is 2, a1 is 6, and you just go up, right, by this formula. You can see all those AMs, they are just integers, so I can go with remainders of the things. Okay, now, all we need to do is we just find the pattern of the formula, right? So let's start from the first one. Okay. So here is, we start from the, this is A. The first one is, so this is the AN, and here is the remainder, right? Okay, by 5, okay? And divided by 5, divided by 5, okay? All right, so the first one is 2, and the second one is 6, right? So this is a0, a1. In terms of remainder, so this is 2, and this is the remainder is 1, okay? All right, then we can just keep going. This is -1, right? Because we just applied this formula. So this is -1. So -1 is the same as 4, right? So when you divide by -1 is just 4. All right. Okay. So then we just keep doing. We just use those positive ones. So for this one will be 3, right? And then the next one, again, you get -4, -1, so which is 4, and then you have you get this 1. This is 1, and you get -3, right? You get -3, but -3 we know it's just 2, right? Okay, so then the next one is 1, and again you get -1 again, which is 4. All right. So clearly you see. So here we get a pattern. So the pattern is 2, 1, 4, 3, 4, 1, 2, 1, 4, and it is going to repeat itself, which means this is cycle that has 6 numbers, right? It's a 6 cycle, so I put a 6 cycle. Now, you start from, so keep in mind, so we start from n equals 0, and all the way is to n. All the way is n equals to 2020, right? 2020, okay? So total here we have 2021 numbers. So let's find the remainder when divided by 6. So 2020, you divide by 6, right? So this is 18 and 22, so 3 is 18, and this 41, so 6, 36, so remainder is 5, right? So you get the remainder is 5. Now, if you see which one the remainder is 5, so we identify it's 4, right? Because the remainder is 5, so get identified as 4. All right, so the conclusion, A 2020, the remainder is 5, is 4. Is 4 when divided by 5. All right. Okay. So now, if we review the solution, so what is the key point? The first key point is we realize if A is a solution, then 1 over A is also a solution. Okay. And then we are able to use the equation, right? So we can here, right? We'll put it here. So we can use the equation to reduce the power. We can reduce to the previous one by this. So here, this is the key. If you look at, if you just care about the remainder when divided by 5, we have this recurrence relation, right? We have this recurrence relation. And then we find if you plug in 2 numbers, the first one is A0, which is 2, and A1, which is 6 by the other formula. And then if you plug into the sequence, which is right here, and then we identify a pattern. Right? We pattern is 6 cycle, and then you just find the remainder when divided by 6. Next, let's problem number 11. So here we have 3 numbers x, y, z. The first condition says 3x, 4y, 5z is a geometric sequence. And the second one says if they are reciprocals, it's arithmetic sequence. And what we find is x over z plus z over x. All right. Now, what we want to do as the first step, let's translate geometric sequence and arithmetic sequence into equivalent algebraic relation. All right. So this is geometric sequence. What does it mean? Okay. Just means you have the common ratio, or we can just say the 4y squared equals to 3x times 5z, right? Because this is equivalent to the same ratio, right? This is equivalent to say, okay, 4y over 3x equals to 5z over 4y, right? So they have the same ratio, which is equivalent. Now, as for this arithmetic sequence, okay, so we just have 2 over y. Twice of the middle equals the sum of the other 2. So this is 1 of x plus 1 of z. I can recombine into one fraction. So this xz and plus xz. All right. So basically we have 2 equations, right? So this is the first equation, and then we have the second equation, which is that. Okay. So let me put it here. Okay. So we have 4. Oh. Okay. So we have 4y squared. Which is 16y squared, that is 15x times z. So this is equation 1. And then we have equation 2, that is 2 over y equals to x plus z over x times z. So this is my equation 2. Now what we want is, we want to figure out x over z plus z over x. Okay. So let's simplify this and combine into one fraction. So this is xz times x squared plus z squared. Now, as I put in the hint, okay, so as we put in the hint, okay, so basically you see x and z and xz, so they have 2 equations, they are given by y, so we expect we should change everything to y. So we hope, so the strategy is want to switch to y. Switch to y, okay? So how should we do that? Well, then of course we try to write this as things that similar to the term like this, x plus z over xz, and this is xz. Now let's do it. So this is x plus z as it is put in the hint, and minus twice of xz over xz, right? Okay, so then this is x plus z squared times xz and minus 2, right? Now let's try to connect this with that. Okay, so then we have xz over xz squared times xz and minus 2. Now, for this one, we can just plug into what we have here. So by 2 and 1, let's plug there. So 2 over y squared, which is this term. All right. And then for this, we have equals to, so this is 16y squared over 15, right? Okay, so this multiplication. And then let's see what we get. So we get this 4 over y squared times 16y squared over 15. Okay, so then I can do the cancellation. And what we end up is 64 over 55. Okay, so that's what we have. So we get this part equals to 64 over 15. And then the whole thing, because this one, so this one is x plus z squared over xz minus 2. This is 64 over 15. So we end up, this one is 15 to the 34, so which is that. All right, and then of course, if you add the problem asks for the sum of the numerator and denominator, right? So we have 34 plus 15, which is 49. Okay, so here the key point is we use algebras to combine those fractions, and we try to express things xz in terms of y, right? Try to match those expressions x plus z over xz. They'll just play around the algebra, and then we have the cancellation. We get a fixed number. Okay. All right. Now let's look at the problem 12. Okay, so problem 12 says we have a 4-digit number. It satisfies the following. So it's the thousandth digit and the 100th digit are the same. It's a 10th digit and the 1st digit also the same. It's a perfect square. All right, so we need to figure out that number. Okay, so given those assumptions, we can write this number. So this number is m squared because it's a perfect square. So I can denote it's just m squared. The 1000th digit and the 100th digit are the same. So I can write this just a and a, right? And then I have this 10th digit and the 1st digit is b. So it's AABB, right? All right, so for this one, you see I can write as 11 times A0B, right? This is 3-digit and the middle one is 0, right? We just write it as that. Okay, so now you see, because this 11 is it's a prime number and n is, okay, I get n is must be divisible by 11. And this implies n can be written as 11 times some number, I say it's k, right? Okay, so now let me plug this back into the equation. So what we have is 11k squared equals 11 times AOB, okay? And then I have just 11k squared equals to AOB, okay? So the 3-digit. Now from here, it's clear, right? From here, it's clear the k, which means we are looking for integer, right? Square multiplied by 11 is 3-digit number, and the middle one is 0. So for the choice of k, so k obviously k has to be no less than 4, and it cannot go beyond 9. Then all you need to do is you check one by one, right? So okay, I can check 4, 5, 6, 7, 8, 9, and to see which one is plugged into the expression is going to give me a 3-digit number. The middle one is 0, and we can figure out it's just 8, right? So let's do it. So it's 64. So okay, so 11 times 8 squared times 8 squared. So this 11 times 64. Okay, so this is 64, right? 64. We just get a 704. So okay, so then you see there's 0 in the middle. Okay, so now so this tells us what is A. A is 7 and B is 4. So this number is 7744. So this is what we have, and this one equals to this n. So n is 88 squared. Okay, now let's look at problem number 13. So problem number 13 says there are 6 people, 2 in red, 2 in blue, and 2 in yellow. We are looking for the number of all possible arrangements such that no 2 people in the same color stand next to each other. All right, so what we can do is we can consider the opposite case. So here I consider, so solution. Consider the opposite case. The opposite case means at least 2 stand next to each other. So at least 2 in same color stand next to each other. Okay. All right. So then we have 3 situations. Right? Either we have 2 red, they stand next to each other. Blue stand next to each other, or yellow, they stand next to each other. Of course, there are overlaps. So we need to use a Venn diagram to figure out the total number of cases, the total number of opposite cases. All right, so we look at 3 situations. So this is, let's say A, this is B, and this is C. Okay, so A is, we have 2 red, they stand next to each other. B is 2 blue, they stand next to each other. And the C is 2 yellow, they stand next to each other. Okay, so then what we have is we're looking for the union of these 3 situations, right? Because we say at least 2 in the same kind next to each other. Okay, so we need to calculate the total number of situations in the union. So for here, what we use the inclusion exclusion principle. We have formula, right? So this is inclusion exclusion principle. Okay. So the number of elements in the union equals the number of elements in A. So this one represents the number of elements. So this just means the number of elements. All right, so it's the number in A plus number in B and plus number in C, and then minus the number in the intersection of A minus the intersection of AC minus the intersection of BC, and then you have to add the common overlap back, right? So this is the formula, inclusion exclusion principle, if you have 3 sets. All right, so then what do we need to do? Calculate just one by one. Let's first calculate A, because the other are asymmetric. Let's calculate the number of A. So A is 2 red ones. So let's record 2 red ones stand next to each other. Okay, so how many do we have? Well, since 2 red ones, so let's 2 red ones, and then we have those are blue and okay, so blue and yellow. Now 2 red ones, they stand next to each other. We didn't consider that's 1 person, right? So that means you have 5 persons. So it's a 5 factorial. But 2 red one, you can also switch their position. So 5 times 2. So this is in A, all right? So this is in A. Now let's calculate what is A intersect B. Intersect B means 2 red and 2 blue, they all next to each other. 2 red, 2 blue next to each other, and yellow doesn't matter, okay? So for this case, we say, all right, so that means we can consider this is basically it's 1, 2, and 4 person, right? Because if they combine if they stand next to each other, you can say as 1. All right, so then in this case, we have it's 4 factorial, right? So this is, we can combine them right here. All right, okay, so this will be 4 factorial, and then you can switch the red one, and you can also switch the blue one. So this is what you have at the intersection. All right, so now let's calculate the intersection of all 3, right? Okay, so that means they're all stand next to each other. Blue, 2 yellow, 2 red, and 2 blue, right? Okay, so that means you can consider as just 3 person, right? All right, so this will be 3 factorial, and then you multiply for each pair, you can switch them. So it's 2 times 2 times 2 and times 2. All right, now let's plug into the formula. What we have, let's calculate that. So this equals to the first one, 5 factorial, because you have 3 copies. So 1, 2, 3. So you multiply by 3. And then you minus 4 factorial times 2 times 2. Again, you have 3 copies. So you multiply by 3. And the last one, you just add it. Okay, so only 1 copy. So it's the 3 factorial with times 8, right? Okay, let's calculate this. Oh, this is there's 2 here. Don't forget there's 2 here. Okay, so this multiplied by 2 and times 3 factorial. All right. Okay, so then if you get it here, you have this is 20, and this is 24 times 12, right? 24 times 12, and then you plus 48, right? Okay, so now you calculate this, you get 72. This is 20, and this is what we have, right? Okay, so this is 480, right? 480 is the number of opposite cases. So this is number of opposite cases. All right, so the number of valid cases equals to 6 factorial. So 6 factorial is we don't consider any restriction, and then you minus, right? So we can, okay, so minus this invalid cases minus this 480, right? So that's you basically just go back to the same 480, which is 240, right? 240. Okay, so here what we do is if you go with the direct method, then you probably have to deal with, you have to do caseworks, right? There's a bunch of caseworks. But here I choose to go with the opposite case. Then we can just apply. We can use the Venn diagram and apply those standard inclusion exclusion principle. And then we figure out each case. Because each case is very simple. The only trick here is if two people they stand next to each other, we can consider as 1 person. And then we just do the permutation and multiply. And then don't forget, because these 2 people, they can switch. They just multiply by 2. Okay, so that's what we have. All right, now let's look at problem 14. So problem 14 says we have 3 point P that moves along the line, half line OA, we need to find when this angle CPA attains the maximum value. All right, so if you have learned calculus, right, so we know like in calculus, they're powerful tool to figure out the maximum minimum. You can take a derivative. But here, let's say we don't know anything about the calculus. So we need to find a different way, right? Some clever way to figure out when the angle attains the maximum. So here the point is, because we are care about angle with a fixed line segment CB, and if we recall things from a circle, like when we have, like if you fix a circle, if you look at angles that opposite to this line segment, when those angles are the same, we know like if they are all on the same circle, so that's we have those same angles. So what I mean is this: suppose I have a circle. I say this is the CB, right? Okay. So if I have all the points on the circle P, right? If I look at different points, now those angles are all the same, right? They're all the same. So those are inscribed angles. Okay. So they're the same. Okay. Now, if I have angle outside, right? Let's say, okay, so if I have angle outside like that, then obviously this angle is less because you can do that. It's very, see, this angle is less than angle P, right? It's less than angle P. This one is equals to angle P. So if you have angle that is inside, if I have angle that is inside, and this guy will be bigger than angle P. So have this picture in your mind. You say, okay, when I want to angle to attain the maximum, so then what you should have, this is 60. Okay, so here is 1, here's 3. So then you see, okay, so it looks like I should have find a circle that's tangent to this half line. And if this is the P, okay, so this is O, this is a half line, so this is C and this B. Now, if it's that, if it's a tangent, then this one is going to be the largest. Let's see why. Because if I draw that, right, so this is the angle. If I choose any point of P on the half line, maybe I use the yellow one. So this will be outside, right? It's outside of the circle, just like the picture here. This guy will be less than the angle P, right? Because this one is the same. This one is the same as equals to angle P. So outside will be less than the angle P. All right, so now, so I hope that you're convinced that to attain the maximum, what you should have is the circle, right? Increase the circle and it touches the tangent to the half line OA. All right, so let's say we're okay with that. So I'm going to erase those. All right. Okay, so now let's see how should we figure it out. In geometry, there's one important approach. If somehow you couldn't find an easy way to solve a geometry problem, then you should look at is whether you are able to find some similar hidden, like similar or congruent triangles. Very often, if you are able to find similar or congruent triangles, not very obvious, then you're quite close to solve the problem. So for this one, you see, let's identify similar triangles. So this angle is the same as this angle. Okay, so that's from the geometry on the circle. So let me say this. So if I have tangent, so this is tangent line. Okay, so then if I have this is a chord, these two angles, they are the same. Okay, so these two angles, they are the same. All right, now I say, okay, so I have the two angles are the same, and meanwhile, they share a common angle. So I conclude the triangle OPC, this is similar, so it's similar to triangle OBP. Okay, so then you say, let's say this is the X. Okay, so I know this one is 1, right? So I know this one is 1. And we have this one is 3. Okay, so this is 3. Okay, so then I can set up a ratio. So it's X over, so it's X over 3 over 4. So because the whole thing, this is equals 4, equals to, this is 1, right? So it's this angle is the same. So it's 1 over X, right? It's 1 over X. Okay, so now from here, I can get X squared equals 4. So I get X equals 2. So we get x equals to 2. So x is 2. Now, if x is 2, let's look at the triangle. So let me single out this triangle. So this is OPC. This guy is 60 degrees, and this is 1, and this is 2. Now, when you look at this situation, and we quickly realize this is special triangle, right? Where let's recall, if I have special right triangle, so this is 60, this is 30, then this will be 1, this will be 2, this is the square root of 3. All right, so that's the situation we have. Okay, so we get this one is, this one is right triangle. It's 90 degrees, right? So this is 90 degrees. All right, so if this is 90 degrees, we get this one is 30, and this is also 90 degrees because of similarity. By similarity, okay, we get the angle OPB is also 90 degrees, and then we get the final answer. This one will be 60 degrees. Okay, so that's how we get 60. All right, so here the main point is, we first of all, we figure out in order to get the maximum angle, you should have a tangent to the half line. Now after that, then we just we realized some facts from the circle geometry, and we identify two similar triangles. We figure out the x, right? And then we say, okay, so if I have situation like this, 1, 2, 60 degrees, okay, I just quickly realize this has to be the right triangle, the special right triangle, 1, 2, the square root 3. All right, so then we figure out the angle, which is 60 degrees.